Assalamu alaikum. Hello and good day, everyone. This is an I section, and what we want to do now is to determine the moment of inertia of this I section. For you to get moment of inertia, you will have to get centroid or center of area first. Starting with the centroid, we already know the steps for calculating centroid. Thus, you have to identify the axis of symmetry of the section. So looking at our section now, you can see that it is symmetrical along a y axis. When you divide it into two vertically, what you will have on the left side is exactly the same with what you have on the right side. So the next thing is to divide the section into equal parts, or rather into some parts. So we divided this into three rectangles. That's rectangle A, B, C, D, rectangle E, F, M, G, and rectangle N, H, J, K. Okay. After dividing the section into parts, then you calculate the area of each part. So area 1, that's A1, is for rectangle ABCD, which is 100 by 20. 100 by 20 is 2000 millimeters square. The next thing is the second area, that's area of rectangle EFGM. So rectangle EMGM is 150 by 20. So we have 20 times 150, which is equal to 3000 millimeters square. Then the last rectangle, which is LHJK, is 200 by 20. You're going to have 4000 millimeters square. After getting the areas, the next thing is to calculate the distance of the centroid from the reference axis. So we have three shapes now. 1, 2, 3. So we are going to have y1, y2, y3. The reference axis in this case is the line KJ, which is the bottom line. So from line KJ up to half of BC, that's y1. So for you to get this, you add J to H, which is 20, then G to F, which is 150, then half of B to C, which is 20 over 2. After computing everything, at the end we have 180 millimeter as the value of y1. That's the distance of rectangle 1, centroid of rectangle 1 from the axis of reference. So let's move to the y2. The y2 is in second rectangle is EFMG. So the distances we need are JH, which is 20, plus half of GF, which is 150. Adding everything gives us 95 millimeters. Then Y3 is just half of JH, which is 20 over 2. So 20 over 2 is 10 millimeters. We are done with that. The next thing is to find the centroid of this I section. We know the formula for centroid is summation of AY over summation of S, which is equivalent to A1 Y1 plus A2 Y2 plus A3 Y3 all over A1 plus A2 plus A3. We can start substituting the values now. So after calculating everything, we have the centroid, which is the y1, as 76.11 millimeter. The next step after getting the centroid is to go ahead and calculate the moment of inertia. Before you do that, we are using parallel axis theorem, so you need to first calculate the individual moment of inertia of each part of the section. So this is the formula for the parallel axis theorem. So let's start with the IG1. That's for rectangle 1. The moment of inertia of a rectangle is given by BD cube over 12. So this is B1 D1 cube over 12. When you substitute the value of B and D, this is B1 from D to C, and D is from B to C. So B is 100 and D is 20 millimeters. Substituting 120 here, the IG1, which is the moment of inertia of the rectangle 1, is going to be 20 times. It's going to be 100 times 20 power 3 over 12. Which is equal to the answer is 66,666.67 millimeter per 4. Remember, the unit of moment of inertia is always in millimeter per 4. So the second moment of inertia, that's for the second rectangle, is going to be 20 times 150 power 3 over 12. In this case, the V is the 20 and the D is the 150. If you look at the paper carefully, calculating everything, we have 5,625,000 millimeter per 4. So this is the moment of inertia of rectangle 2. Then the last rectangle, the moment of inertia is going to be, in this case, 200 by 20 over 12 by 20 power 3 all over 12, which is equal to 133,333.33. So these are the individual moment of inertia. The next thing is to get the H, and we know that the H is the difference between the centroid of the whole section and the centroid of each shape. So for the first one, to get our H1, we subtract the centroid from Y1, because we know for the first rectangle, the centroid is 180, which is greater than the centroid of the whole section. So 180 minus 76.11 will give us the difference between the two centroid, which in this case is 103.89. The H2, that's the difference between the difference between the centroid of the second rectangle and the centroid of the section is going to be 95 minus 76.11, which is 18.89 millimeter. Then the H3, which is the difference between the centroid of the whole section and the centroid of the last rectangle or the third rectangle. So the third rectangle, the centroid is smaller than the centroid of the whole section. So we are going to subtract this centroid from the centroid of the whole section. That's why we have 76.11 minus 10, which is 66.11. The next thing is substituting everything in the formula. That's the parallel axis theorem. To get the moment of the inertia of the whole section in XX direction. Expanding the formula, the parallel axis theorem formula, we have Ix equal to Ig1 plus A1 H1 squared plus Ig2 plus A2 H2 squared plus Ig3 plus A3 H3 squared. So you fix the values of Ig's and values of S and values of H and substitute everything here, as you can see. Once you finish everything, you can add up everything in your calculator and get the final answer. Here, after adding everything, what I got is 45,963,888.9 millimeter powerful. So this is the centroid of this I section with the given dimensions. Thank you.